So, you see a new study pop up, and the headline is promising some huge breakthrough. But how do you know if it's a real game changer or, just a bunch of statistical noise? It's a super important question, not just for doctors, but for all of us. And today, we're going to figure it out. All right, let's start with the one thing that's at the heart of most medical research, the p-value. I mean, if you've ever even glanced at a scientific paper, you've definitely seen it.
For decades, this has been the golden rule. It's kind of the magic number. If your p-value is less than 0.05, boom, your result gets stamped statistically significant. It's been the ultimate gatekeeper for getting research published and for grabbing those big headlines.
But is that really the whole story? I mean, does hitting that one little statistical target automatically mean a discovery is actually going to make a difference in a real person's life?
So what even is a p-value? Well, think of it as a measure of surprise. It basically calculates the odds that you'd get the results you did just by random chance, if the treatment you're testing actually does nothing. So a really tiny p-value means your result is super surprising, which suggests, hey, this effect is probably real.
But here's where things get really tricky. Just because an effect is real in a statistical sense, that doesn't automatically make it important. Let's look at an example from our source material that just makes this crystal clear. Okay, so check this out. Imagine a huge study for a new drug finds that it lowers blood pressure by a single point, just 1 millimeter of mercury. Now the p-value is less than 0.001. That is highly statistically significant. The math is telling us this is almost certainly not a fluke.
So let's put on our doctor hat for a second. Would you actually prescribe this to a patient? I mean, a 1-point drop in blood pressure, from a practical point of view, it's meaningless. It's not going to change a patient's health in the long run.
And this right here, this perfectly illustrates the problem. The finding is statistically real, for sure, but it has zero clinical relevance. This is the big distinction we have to make if we want to be smarter about how we look at medical research.
So, how do we solve this puzzle? Well, it all starts with understanding that there are really two different kinds of significance. And trust me, they are not the same thing at all.
This slide just lays it out perfectly. On one side, you have statistical significance. It's really just asking, is this effect real or is it just random chance? It's a probability thing. But on the other side, clinical significance asks a way more practical question. Is this effect big enough to actually matter for a patient?
You know, a good way to think about it is this. Statistical significance gets you in the door. It tells you that a result probably isn't just noise and you should pay attention. But it is absolutely not enough, all by itself, to change how we treat patients.
So if p-values aren't the be-all and end-all, what should we be looking for? Well, good news, there are much better tools for figuring out the actual real-world impact of a study's findings.
First up, we have effect size. And this, my friends, is a total game changer. Unlike a p-value, the effect size tells you the magnitude of the finding. It answers that crucial question, how big is the difference? Is it a 1-point drop in blood pressure or a 10-point drop? That's what we actually care about, right? And next, we have the confidence interval. So while the effect size gives you one number, the confidence interval gives you a plausible range for that effect. A really wide interval means there's a lot of uncertainty. But a nice narrow interval, that means we're getting a much more precise idea of what's going on. And this quote from the source material just brings it all home. A p-value might just tell you, the drug works. But a confidence interval that says the blood pressure drop is probably somewhere between 5 and 15 points, now that is information a doctor can actually use. It shows the size, it shows the precision, and it allows for real clinical judgment.
Okay, so let's put all this together. Let's create a simple framework you can use to read a medical study like an expert, one that goes way beyond just hunting for that p-value.
Here we go, 4 simple steps. First, acknowledge the p-value. See if the finding is likely real. Then, step 2, immediately go find the effect size. How big is this change? Step 3, look at that confidence interval. What's the plausible range of the effect? And then step 4, and this is the most important one. Ask yourself, is this effect big enough to actually change how we take care of patients?
See, what this framework does is so important. It completely shifts our focus away from the academic question, is this effect real? And moves it to the profoundly practical question, does this effect actually matter?
So, the next time you see a headline about a significant new finding in medicine, I want you to ask that deeper question. Is it just significant on paper, or is it significant enough to make a real difference? Because that, right there, is the question that truly matters.